Good day to everyone who's watching. In our lesson 6 today of vectors, we are going to talk about the parallel vectors and the collinearity of points. If we have vectors P, Q, and dr, and we have that the PQ is equal to K dr, where the K is a scalar, then those vectors PQ and dr are parallel. Now, when we go to collinearity of points are said to be collinear if all of them lie on a straight line. So how do we prove that? We prove that if we have our two vectors that are parallel and that those two vectors have a common point in them, then that means that those vectors lie on a straight line or on the same line, and therefore the points themselves become collinear. That is, if we consider points A, B, and C, we form vectors in between these points. That is, AB is equal to KBC, or the K is equal to AB divided by this, where the K is a scalar. So if we manage to get or to achieve such a thing, where we have a point which is common, the B is there is common, then we also get this scalar here, then we prove that those points ABC are collinear, and also the vectors, they lie on a straight line. Our example 1, the coordinates of P, Q, and R are those ones there respectively. That means that this belongs to that. 18, 2 belongs to Q. The 50 negative 2 belongs to R. So they are telling us part A to find the vectors P, Q, and then QR. The idea of position vectors, the P, PQ, that is going to be my OQ minus the OP. Then when I substitute, that is going to be 18, 2 minus the 2, 4. When I subtract, I'm going to be having 18 minus 2, that is the 16. Then 2 minus 4, that is the negative 2. So that is my vector PQ. Then to find my vector QR, this is going to be OR minus the OQ. So this is going to be equal to, the OR is 50 negative 2, then minus the OQ, which is, so when I subtract 50 minus 18, I'm getting 32, then negative 2 minus 2, I'm getting a negative 4 as my QR. Now, part B, they are telling us to show that points P, Q, and R are collinear. But we need to form vectors. Only that in part A, we have already gotten those vectors there. These are the ones, we have already got them in part A. Now I need to show that my PQ is equal to some constant times the QR. That is what I need to show. First, these two vectors share a common point, which is Q. Then now I need to get this scalar to prove that those two vectors are parallel. Then the points will become collinear. So when I substitute, this is 16 negative 2 is equal to, okay, 32 negative 4. The other side, the right hand side, I'm having a multiplication of a scalar. So I first multiply it. That becomes 32k, and negative 4. Okay, this side 16, negative 2. Then we talked about equal vectors. So that means that the 32k is equivalent to 16. So when I divide both sides by 32 and that way by 32, I get my k value as a half. Then I can conclude and I say, since my PQ is equal to a half, QR points P, Q, and R are collinear. So as simple as that. Now, someone can say that for me, I want to use the QR is equal to K PQ. There's no problem. There's no problem. As long as you get that constant. You see, when I reached here, even if I use this downer one, the y values, I will still get my k as a half. So if someone uses this, you substitute the QR as 32 negative 4 is equal to k 16 negative 2. Now, the other side, you multiply that scalar. That is 16k minus 2k. Then if you try to equate one of them, you'll be getting your k as a 2. As long as you get the constant, this implies that for this, the q r is equal to pq. And you can see, someone can see that this one is the same as this, because when you multiply both sides by 2, from here you will arrive to that. So you will still get the same values, you will still get the same marks, even if you use the other side. Try so much to see that there is a common point in those vectors that you are using, and then you get the scalar.